welcome to the Westin MCAT podcast with your host, Ahmed
and Eric Olson.
Welcome back, everyone, to another episode of the Westin MCAT podcast with Ahmed and Eric. Today, we'll look at nuclear phenomena, specifically different types of decay and what they mean and how to problem solve when you see those kinds of questions on the MCAT. But before we dive into that, Eric, any interesting cases at work today, or is it pretty status quo?
It's always interesting when you're in the histology lab and looking at things under the microscope because you just never know what you're going to see. But what has been actually more interesting to me this week is I've been thinking about, I guess I've been thinking about our listeners and like the things that they're having to go through and the things they're doing. And
Okay.
we have we're doing like a Habitat for Humanity thing here. Are you familiar with that organization?
Yeah.
Yeah. So like, I don't really know how it got set up, but our program was like, hey, like all the residents are going to go and build this house or whatever. And that's coming up at the end of this week. And I was just thinking about like volunteering and kind of the progression of like what kind of volunteer work you do in your medical education journey, so to speak. And I like, as a pre-med, at least my experience was as a pre-med, like we were doing a lot of volunteering. Like you were involved in a lot of different organizations and like you were trying to be in the leadership of those organizations and like make a difference in this way or that way. As a med student, I don't know if I volunteered really hardly at all. I might have found I did find a couple of organizations that I was interested in kind of outside of like, just outside of medicine a little bit more, like things that I was just interested in myself.
Yeah.
I did do like some volunteer tutoring, and then I did some work with an organization that like, well, I won't get into the specifics, but it was like medicine adjacent kind of. But it's been interesting to me because now that I'm a resident and like we have a little bit more structure to the volunteering that we're doing. And I think, it depends on program and things like that. But for us, we do have like some structured opportunities that we're available to participate in. Like this Habitat for Humanity thing is one. But like we have some free clinics and like free skin cancer screening events and things like that. Like they'll sometimes send us to like a conference for some other field or something like that and say like, we're going to do free skin checks and look for skin cancers and make sure people look okay. And so it's kind of cool to be able to like do some volunteer work in your field. And, this Habitat for Humanity thing is not exactly that, but
Sure.
But it's nice to like, I'm not stressing about finding things that will, be relevant or make me look good, but like these opportunities are kind of provided for me. And then, there's opportunities to kind of get involved more in developing new opportunities for service, if that makes sense. Right. Like one of the attendings that I have now, who's kind of a younger attending, she was telling me the other day that like she started the like dermatology section of the like student run free clinic in our area. So like a lot of med schools have a student run free clinic where they work on like Saturdays or something like that. And a lot of times, like you get general practitioners and primary care doctors that are able to go, but sometimes it's harder to get specialty care. And so she was saying like, oh yeah, when I was a med student here, 6 or so years ago or whenever it was, like that was my brainchild. Like I started that. And so it's kind of cool. Like you get some more specialty specific opportunities. But I was going to ask you, like, I know you're just getting into it and we've talked a little bit about like starting to get into shadowing and things like that.
Yeah.
Volunteering like on your mind? Is it something you think about, or is it like down the road at this point you're still kind of figuring out how to study and get all that under your belt?
Yeah, and I mean, don't get me wrong, volunteering is definitely something that's important to me, and like I do, but not in like the medical space. Like for example, like I help like coach on like the weekends, and like it's just a good way to get out.
I love that. Get outside of medicine and do something else that's relevant to you.
Yeah, but like my life right now is like really separated into 4 clusters, one of which is sort of academic, which entails obviously school, research, shadowing, etc. One of them is athletic. So I mentioned on the previous episode that's recently started to involve a little bit more of travel.
Hmm.
Um, and then there is obviously like work, trying to cover as much of my own tuition as I can and cover rent and things like that. And then family, right? So, like, for example, like I mentioned, we have a week off of school. Today, the day that we're filming is a Wednesday. I came home last Friday. I'm heading back tomorrow, and it feels like the time just kind of flew by.
Yeah.
And like my sister's obviously like at an age where like she's growing. So like every time I see her, she's like a little bit taller. And so that's a just long way of saying like, I'm still very much in the realm of like I got like a lot of personal things to take care of. And there's I guess it's a saying, but like you got to take care of yourself before you can take care of others, right?
Yeah.
And so I'm still working on that take care of yourself part. And granted, like I'm not, struggling or anything like that, but it's just there's a lot of things that I kind of want to get accomplished. And
Yeah. There's a lot to balance. New
so
question.
yeah, just taking care of those things. But I think like when you get into medical school, like you like your your concept of volunteering changes a little bit. And it's less to sort of appeal to others' perceptions, and it's more to just
Yes.
like do what feels right.
Do you want to do it? Yeah, like how do you want to help someone, right?
And so the reason I say that is because, for example, like when I'm at squash practice and, a couple of my med school buddies are like just coincidentally walking in and like messing around on one of the other courts, like I'll hang out with them for a half hour and just like kind of teach them how to play and things like that. Like that in its essence is volunteering, but it's not anything I would ever put like on a resume or an application or something. You know what I mean?
Yeah, yeah.
And so it's probably a smaller scale than some other things, but I know like once I kind of get my feet in the door in some of these different avenues that I'm trying to go down, like shadowing, like research, like for example, like once I really like find my like research domain, if that makes sense, like I find the lab or the physician that like, okay, this is something I see myself growing within. I feel like things will change at that point, but right now it's very much, explore everything, cast a wide net, see what sticks. Um, and so once I have a bit more of a routine, I feel like that's something I'll look into a little bit more. But if you find a first year med student that's already volunteering, hey, kudos to them because they got things figured out.
Yeah, I haven't seen any yet. I mean, I was gonna say I feel like once your paradigm shifts a little bit too in that you don't feel like you have to be doing it all the time.
Yeah,
And I think like I want to illustrate it with some of these like screening events and things that we have. Like it's every 2 or 3 months, there'll be like a
right,
day, like a half day, like 3 or 4 hours where they're like, oh yeah, you guys can come and help out if you want. And
right.
I love that because it's like, here's an opportunity. You don't have to be doing this every day. You don't have to be doing it every week, but like when you have time, when you have interest, you can still give back. And I think I like your example too. Like it's not something organized. It's just like, here's something I'm going to do to like help someone. And it's not like,
Yeah.
it's not for the recognition, it's not to prove that I'm willing to help people. It's just who I, want to be. And I think that becomes more important the less you kind of have to show yourself off, which is kind of an unfortunate part of being a pre-medical student.
And it's as little as like helping a classmate with, a certain topic or, agreeing to like quiz somebody or, during application season, like some of your friends will send you essays that they would love for you to read over. Like those are the kinds of things that, I think as an entry point to volunteering are easy because you have a direct connection to the person on the other side. Not to say that that's the only way to volunteer by any means, but I think, I've always been of the mindset that, you always want to just like start slow and ramp up. Like for example, today, how one of my colleagues offered like another classroom session. Like, hey, you want to take this? Like, you'd be great at it, etc. My first thought is like, yeah, absolutely. I'd love to make more money. But then I thought about it. I was like, well, I'm already working 3 weekdays, 3 weekday evenings a week. Does it make sense for me to do four at this stage? Probably not.
Probably
Like
not.
let's feel this out a little bit. So, and to any, I guess most of our viewers are pre-medical school, but like don't feel like you're pressured into like doing what everybody else is doing. Like I feel that so much right now. Like some of my friends stayed in the city to shadow during our week off, and I was like, absolutely not. Like I'm going home. I could not be bothered. You know what I mean?
Yeah.
Like you can log your 30 shadowing hours. I'm gonna log 150 family hours. That's much cooler. So just carve your own path, I think is the moral of the story.
Yeah. Yeah, I like that. It's hard. And when you get into, it depends on where you are, I guess. Because at my undergrad, we had like a pretty monomorphic segment of pre-medical students. Like we all kind of knew each other and we were all
Yeah.
doing the same things. And I found that it was helpful for me to like do to kind of do my own thing a little bit more, you know.
Yeah.
So I took some opportunities that were like kind of outside the norm, and I think that was helpful for me. And it's even worse when you're in med school because you are all like right in the same place and you're doing the exact same thing. And so it's
Yeah.
good to not like compare and want to like come out on top and things like that. But there's so much room for other things in medical school and so many other demands on your time. I think you're doing it right. Anyway, we should
100%.
jump into this material to radiation,
Yeah.
and decay, and things like that.
Yeah. I mean the ABGs, right? Alpha, beta, gamma, right? Um, I don't know if that's a thing. It sounded cool, so I spit it out. But
I don't know. I
we'll
haven't heard that, but it made me
we'll
think of
roll it.
arterial blood gas, which I think you might have talked about with Jaden like the first week we did the podcast.
Honestly, I maybe. Yeah, my memory is once you get into medical school, your memory starts operating on 1 to 2 week
It
cycles.
gets
So
shorter and shorter. Yeah.
yeah, I couldn't tell you what happened 2 weeks ago, to be honest. But in any case, um, it's really like with this concept of decay, like it really just comes down to just understanding like what the notation is saying,
Mm,
right? And so an alpha decay is the emission of an alpha particle, right? So now the logical question becomes, what is an alpha
what is
particle?
it? Particle.
Alpha particle is just a helium atom. That's essentially all it is, right? So you got two protons, you got two neutrons. And so where people kind of mess up the decays is like looking at different atomic numbers and atomic masses and figuring out, what would have happened. Right. I think it's really, really important to get comfortable with, okay, if I have the loss of an alpha particle, I should lose four from my atomic mass,
Hmm.
two from my atomic number, which is the number of protons, right? Um, I don't know that there's another way for alpha decay specifically to conceptualize it. I think it really just comes down to knowing that alpha decay is a helium atom.
Yeah.
Um, as far as the MCAT goes, like you don't really get asked much beyond that. Like you'll never see a question which, asks, which type of decay is most likely here. Like none of that stuff. Some folks may remember, alpha particles from like the Rutherford gold foil experiments, right? None
Is
of
that what he was
that.
shooting, or was it just protons? Was it alpha particles?
I think it was alpha particles. Yeah.
All right. I love the
Um,
Rutherford gold foil experiment. That's a
yeah.
classic. That's one that I remember of all the ones to remember.
Yeah. And I mean, I think he was just shooting alpha particles that were sort of deflected by these protons in
Yeah,
the
so
in the
like most
nucleus.
of them went through. This is a tangent, but most of them
Yeah.
went through the gold foil. It was like a super, super thin sheet of foil,
Hmm.
like atom's thick, right? And he was shooting these particles, alpha particles, I guess, at this sheet of gold. And most of the alpha particles, like he had a detector array behind it or something like it was like a
Right.
fluorescent thing that was like emitting photons when they were hit by the alpha particles.
Yeah.
And they saw that like all these particles were going straight through the gold, except that some of them would like bounce off and come back the other way. And the idea
Yeah.
being like the thing that they learned was that the nucleus, which was like the positively charged part of an atom, was like super, super small. because only a
Right.
few of these alpha particles were coming back, whereas most of like the space of the atom was just kind of empty space, which we know now is kind of the electron cloud.
Right.
I don't know why. That's like just the idea of like this super, super thin gold foil. I don't know. I remember learning about this experiment in like an AP chemistry class. And
Yeah.
for whatever reason, like I just thought it was cool and it stuck with me.
Hey man, like if you find something interesting, like it makes learning a lot more fun.
You got to make yourself interested in this stuff, you know?
100%. Uh, I'm just pulling out my periodic table here. Um, so, for any of our listeners paying attention, right, we talked about alpha decay, right? It's the loss of a helium atom.
Hmm.
And, full disclaimer, I don't know if any of these, elements are actually radioactive or not, but like if we have, we'll take one of the lanthanides and say, samarium is 62 is the atomic number, and 150, let's say 152 is the atomic mass, so we've got an isotope there, right? If we've got an alpha decay, right, so 154.62, we're going to take 4 off the top number, or the bigger
Hmm.
number, 2 off the smaller number, right? That's going to take us
Hmm.
to 150 and 60,
Yeah.
right?
Yeah.
And
Beautiful.
so the thing that I really want to emphasize here is like when you get a question that says, okay, what is the identity of, the daughter nucleus, right? Never, 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 never answer that question using atomic mass.
Hmm.
Always answer the question using atomic number, because think about it, right? Uh, you know, when the periodic table was made, right, the single distinguishing property between elements was the number of protons.
Number of protons, atomic number, exactly.
Right? And it's not number of neutrons, right? Because those are isotopes.
Yeah.
Iso for same, tope for type, I guess. I
Sure.
hope.
That sounds
Um,
good.
in any case, uh, right, like having different number of neutrons doesn't change the identity of the element.
Yeah.
So I think that's the one thing I really want to emphasize there is like when given those questions, always rely on the number of protons. And it's not
Yeah.
just alpha decay, it's beta plus, beta minus. Always rely on the number of protons to identify the daughter nucleus.
Yeah. I was going to say, almost tangentially, like you said, I don't even know if this is a radioactive element, but I think like, the atomic mass that we see in the periodic table is like an average of
Correct. Yeah.
the frequencies of each isotope. And I would say that probably every element, every type of atom has an isotope that is radioactive, right?
That's
Like maybe
true.
your example was like 164 over 52, right? It's like maybe 164, or was it backwards? 154 over 62. Doesn't matter.
154 over 62. Yeah.
So like maybe the 154 is like stable. Maybe 155 is really unstable and will decay
Right.
somehow. And maybe 153 is unstable, right? So I think every element like probably has isotopes that are unstable. I wouldn't I wouldn't quote myself on that because I don't know all the isotopes of all the atoms, but I would imagine that, most, I mean, you think about carbon, which is like the most stable
Yeah.
thing we have, and like carbon 12 being the most abundant isotope. But like carbon 14 is what we use in carbon dating because it is
Yeah.
unstable and has radioactive decay. And so I think like they could come at you with any sort of element, like any element,
For
and say
sure.
it's going to be radioactive and like how is it going to decay. So don't let that throw you off. But I agree, like my number one priority in any of these scenarios, like you said, between alpha decay or any other type of decay, is going to be looking at the atomic number, right? And
Yeah.
then the atomic mass is going to come second. And so when you have alpha decay, you look at that atomic number. If it's 52, then you look at 52 and you say, okay, I'm losing 2 protons. So my atomic number is going to come down by 2, and the new atomic number is going to be 50. And that's how you determine what the new atom or what the new element is going to be. And then you can figure out the mass from there. Again, as you said, by subtracting 4 from the atomic mass. But I think, the principal problem that we're solving for here is what is the atom or what is the new element, and you do
Right.
that with atomic number.
Right.
And then, as we'll get into here, let's talk a little bit about these other types of decay. You have, did you say beta plus and beta minus? I think when I took I don't know if this has changed. When I took the exam, it was like when you talk about beta decay, it was like this is an electron. Like you're losing an electron, like that's it. And I think more recently there's kind of this talk about beta plus decay, which would be
Yeah,
using a positron, and we'll kind of talk about what that is. But I think in my experience, at least, and I'd be interested to hear if maybe you have experienced differently, but when I see beta decay on a test, it's like beta decay, we're talking about an electron. And a lot of times, they might define if they want to say beta minus or beta plus. But when I think of beta,
yeah.
I think about an electron being lost.
I don't know for certain. I would assume beta minus is the more common of the two, though, just based on,
Mhm.
anecdotally what I've seen more. They will almost always, though, explicitly define them, though.
Okay, yeah.
What's cool though is the the name tells you what's emitted. And from there you can kind of work backwards to balance
Yeah.
the charges.
So beta minus, you're losing an electron.
Right.
Beta plus, you're losing a positron or a positive charge with no mass.
Right. And so I really love the idea of working backwards here to make things make sense because the overall charge, right, on the isotope or the element isn't going to change, right? Like we talked about alpha decay. The helium atom's neutrally charged, right? So the charge is going to stay the same. So let's think about this for a second. If I have beta plus decay, let's start there. I'm ejecting a positive charge,
Mm-hmm.
right? Which means I need to be losing that positive charge from somewhere,
Mm-hmm.
right? Otherwise, things are going to get thrown off. And so what ends up happening is you can sort of reason then that a proton has gotten converted into a neutron,
Because you're losing one positive charge.
and then the positive gets
Okay.
ejected,
Yeah.
right? Whereas beta minus is kind of opposite. If I'm losing an electron or an electrino, technically, it makes sense that a neutron is getting converted into a proton, right? Because if I have a plus and a minus as my products, it makes sense that the precursor was a neutron,
Was a neutral. Yeah, because they cancel each other out. Exactly.
right?
You touched on this, but I think it's important. I don't think explicitly state this. But alpha decay, the charge is 2, the mass is 4. With beta decay, regardless of if it's plus or minus, the idea is like you're losing a charge one way or the other. You're ejecting either a positive or negative charge from your nucleus, but there's no change in mass, right? And you think
Yeah.
about like, and I don't really know what you're talking about with electrinos. I'd be interested to hear what you have to say about that. The way I always have thought about it is just like I was thinking about this today. It's like if you have like a bowling ball and that's your nucleus,
Yeah.
then losing an electron or an electrino, as the case may be, like, does it have mass? Like, maybe technically, yes, it has like a little bit of mass, but
Yeah.
losing that is going to be like losing like a grain of rice off of your bowling ball. Like, it's so small and so like,
Mhm.
and even like I would posit that it would be a much greater magnitude of difference. But just for the sake of an illustration, like if you lose a grain of rice from your bowling ball or lose an electron from your nucleus, the difference is going to be so minimal that it's not going to make a change to your overall mass, right?
Right.
But what do
Right.
you tell me about electrinos? And it's not going to be tested on the exam, but I'm interested to
No.
hear.
So I'm gonna preface this, by saying if we have any young Sheldon fans out there, and I'm personally like I've never sat down and just like watched the series, but my sister, for whatever unknown reason, is a huge, huge fan of that show. And
Hmm.
she's the type of person that just like that throws it on. Like she's seen the entire season or the entire series like 90 times by now, but it's just like she
Must
just
be
doesn't
good.
stop. She gets to the end and it's right back to episode 1. There's an episode in there where Dr. Sturgis is having sort of a psychotic episode on the roof because he didn't get nominated for the Nobel Prize in physics,
Hmm.
which went to I think somebody who like discovered or not discovered, but like did some work with quark or whatever. But like the other like nominee, I guess, was working with like neutrinos and stuff like
Mm,
that. And he's on this roof doing Tai Chi. And he's like, oh, like I think I just felt a neutrino. Like I'm getting bombarded by these subatomic. Anyway, it's goofy science at best. But in any case, the suffix ino in this context, you can think of it as just meaning like really, really tiny
yeah,
particle,
yeah,
right? So a neutrino is a neutron, but with much less mass,
yeah.
right?
Negative mass. Yeah,
The positive equivalent of a neutrino is called a positron. So
yeah,
similar, but not the exact same suffix. So it's this positive charge, essentially with the mass of an electron. You can think of it. So like
okay,
more or less massless, but with the charge of a proton. Electron versus electrino doesn't really make a difference just because we consider both to be massless anyway.
sure. Yeah, yeah, because it's
Um,
so small.
exactly. But you made a really good point there, Eric. Beta decay, atomic mass does not change because you're just converting from proton to neutron or vice
Right,
versa.
right.
Um, and so and I'll do a much better job than the last episode in terms of not spoiling a question, but um there may be a question out there on the internet somewhere,
Maybe. Who knows?
potentially, where you may be asked to go from one element to another,
Hmm.
right? How many different decays must you undergo? Based on what Eric just told us, if there's a change in atomic mass, that guarantees that you need alpha decay.
Right, because there's no
Guaranteed.
other decay type that we're talking about that causes a change in mass.
Absolutely. And then from there, you can use beta plus or beta minus to fine tune, the atomic number,
Yeah,
right? Whether you want to bring it up using beta minus decay, or if you want to bring it down using beta plus decay, you can make those adjustments, but you need to first get the atomic mass right
yeah.
using alpha decay.
I don't know if you, I'm interested in your take. I've seen and I've had some students who have had success with kind of writing out these, for lack of a better term, equations with these types of decay. Like on the left side of your equation, you say, I don't remember what that element that we were talking about, what the name is, but I'll use carbon because it's easier for me. You
Sure.
have like carbon with mass of 14 and atomic number of 6 on the left side of your equation. You say, oh, we're going to do, an alpha decay of this
Yeah.
carbon. So then you draw an arrow to the right side of an equation and you have an alpha decay particle or a helium nucleus, which would be, alpha with a mass of 4 and an atomic number of 2. And then you write, plus some other entity, and you're figuring out what that other entity is, which is going to be the product of your alpha decay.
Right.
And then you can, look at your atomic or your periodic table, excuse me, and see, if carbon is atomic number of 6 and we lost 2 protons, then what has an atomic number of 4? And the answer is beryllium, maybe, right?
Atomic number 4 would be yeah.
Okay, cool. So then you have like
Yeah.
beryllium with 4 on bottom, right? Because 4 plus 2 equals 6, working backwards. And then you'd have a 12 on the top because you lost, or excuse me, a 10 on the top because you lost 4
Right.
units. Um,
Yeah.
you can do the same thing for beta decay, both positive and negative. And again, you would start with whatever on the left side. I'll just run through one for the sake of completeness. If you had this same kind of carbon setup with 14 mass, so 14 on top and 6 on bottom being your atomic number, and you said we're going to go through electron or beta decay, beta minus decay, I guess we could say. So then on the other side of your equation, you'd be yielding one beta particle with a -1 charge, and you would have to then increase the atomic number of your product, right? Because you're effectively gaining a proton, excuse me, as you're kind of converting a neutron into a proton.
Right. Right.
And so then you'd have 14 on top because there's no change in mass. And
Yep.
instead of 6 on bottom, you would have a 7, which is nitrogen.
Nitrogen.
Okay.
Yeah.
I used to know like the elements really well, and I don't use the periodic table nearly as much anymore. So,
You
but
mean you don't use the
like
periodic table as a dermatology resident?
not a ton. I mean, it comes up once in a while. Um, So, like, I think this is an effective strategy. And I think if you really struggle with these sorts of problems, it can be helpful. I think it's a little bit
Yeah,
time consuming. And I think the goal, depending on how confident you feel with these sorts of problems, the goal would to be, to potentially use this strategy on a number of practice problems and get to the point where
for
you feel
sure.
comfortable kind of doing it without having to write everything down because you hate to lose a lot of time on something like this. But at the same time, I would say, if you have trouble with this sort of problem and conceptualizing which way you're moving and how these decay problems are changing a nucleus, then I think it would be an appropriate strategy to try out. But I don't know,
Yeah.
what has your experience been
No, I second that completely. Write it out, treat the mass and the atomic number as separate entities,
separately? Absolutely.
and then sort of work from there. Um, and kind of building off of what we said, right? Like I mentioned, if you need to change the atomic mass, use alpha decay, and then from
Hmm.
there fine tune with beta minus or beta plus. And our listeners may be wondering, then what does gamma do? If you can only fine tune with beta, what does gamma do? The nice thing for anyone listening, gamma decay is just the emission of energy. There's
Just
no
energy.
change to the atomic number or the atomic mass. If it's just energy, it's just gamma and vice versa. That's really all there is to it.
Yeah. Yeah.
That's it.
That's the easy one, right?
Yeah.
You don't have to think too hard about it. Um,
Yeah.
I will say, it's kind of interesting that if you look at like an electromagnetic radiation spectrum,
Yeah.
that, I've seen on tests before, that like gamma radiation is on that spectrum. Like you can see it when you have one that's kind of what's the word I'm looking for? Like demarcated, delineated, like showing what
Yeah. Yeah.
the different types are. Like this is visible light and this is infrared,
Yeah. Yeah. The
and
labeled ones.
gamma
Yeah.
is like super short wavelength, super high frequency, which means very high energy. And I
Yeah.
think those are nice. And I just say this as kind of like a test taking strategy, but like if you had a problem that was asking, like maybe you would find something about gamma decay somewhere else on your exam. And on another part of your exam later, you might have that spectrum where it shows like all the different types of electromagnetic radiation. And like sometimes you can find figures and things like that in certain parts of your exam that can help you answer questions on other parts of your exam. So like if they were asking you if gamma radiation was high energy or low energy, or if it was high frequency or low frequency or something like that, maybe you don't know the answer, but maybe you might like come across a figure later in the text that would show you, here's gamma radiation right here. It's on the electromagnetic spectrum and it's super high frequency. I think the chances of that
Yeah.
particular scenario occurring are probably pretty low.
You
But
know
the
what?
idea being, sometimes you can see things in some of these figures that they give you that could be helpful elsewhere.
It's so funny you mentioned that because I remember this so clearly. When I took the MCAT, I had a question, and I won't get into the specifics, but it was asking me, which of these colligative properties is responsible for whatever effect, right? And I'm like, okay, I've narrowed it down to two. I know it's one of these two. Not sure, flagged it, moved on. Came back to it later. I kid you not. I'm reading a passage later and it explicitly says,
Mm-hmm.
the particles were slowed down at the periphery of the pen because of blank. And I
Mm-hmm.
was like, wait a minute. Let me go back to that question. I was like,
It's
oh,
really familiar. Yeah.
now, how likely is that to happen? I don't know.
Not
Probably
super
not.
likely, but not impossible, apparently.
But it's funny. Ever since I read this book as a kid, and I can't remember what it's called, and I remember somebody like refreshed my memory, and maybe you'll know what I'm talking about, Eric. But it's this book about these kids that get sent to this like academy. It's like this really advanced place, and they have to take this test to stay in. And the test is like impossible. Like I can't remember how many questions it was, but like they're halfway through the exam and they have absolutely no clue what is going on. But the second half of the exam, those questions had the answers to the first half and vice versa.
Mm-hmm.
And so if you were particularly astute, you were going to get 100%. And if you didn't pick up on this, you would more or less score like chance. So whether that was 25%, 20%, whatever. And I remember reading that book and I was like, it just kind of, in a really like weird way just kind of opened my eyes to test taking strategies. And
Yeah.
ever since, I can't remember what the book was called, but somebody someday is going to remind me. But
Sorry,
um,
I don't know if I've read that one.
all good. But ever since then, I was like, okay, like you can really, especially for a multiple choice exam, you can really learn to
Okay.
use the exam sort of against itself. And I know we talk about this a lot, but it's just, strategy is so important. Like strategy applies to every question. Content only applies to a handful, right?
Yeah.
Not to say that content is not important. That's not at all what I'm saying, but sometimes you get these gifts and you'll never know you got them if you're not paying attention. And
Yeah.
so I think just always, think critically, use the information at your disposal, and you'll be surprised at, what you can do with it.
Yeah. I would add, and this is a little bit outside of the specifics of what we're talking about in terms of decay. But as far as strategy goes, and we do talk about this, but honestly, probably not enough. I think, this is kind of a content podcast, and so we spend time talking about specific principles and things for the most part. But I agree with you, and you said something really important, which is that content, it may or may not be there for a specific question. You could spend all the time in the world, preparing for the Krebs cycle, and it may, like there may be nothing about the Krebs cycle on your exam. That's not entirely outside the realm of possibility.
Yeah.
But if you think about strategy and you practice different test taking strategies that will be helpful for you, then those things will certainly be helpful for you. And I believe in studying content. I really do. But I think that you could study all the content in the world and really know it down pat, and you could still do poorly on the MCAT.
Yeah.
Conversely, I think that you could study some of the, I mean, I wouldn't say you couldn't study the content, but I think having good test taking strategies is going to be a surer way to do well on the test if you pair it
Yeah.
with good content review. I think,
Yeah.
the content review is kind of the base. And my experience, and maybe you'll disagree with me, but I kind of felt like once I had the content down, that it became a question of like, can I learn what I need to know about the test itself? Not about what's going to be on the test, right? But about how they're going
Yeah.
to ask me questions and how they're gonna use the passage, and how the questions are going to relate to the passage and things like that.
Yeah.
Because at the end of the day, like I felt like most passage questions were not questions of how much you understood the content. They were questions of like, do you understand what's going on in this passage? And they'll give
Yeah.
you those little hints and tips within the passage. And yeah, I just felt like the content was kind of like a base layer of understanding that you have to have. And then they really want to test kind of, are you able to critically think through the way that we're asking things, and how
Yeah.
we're asking you to get back into the passage and things like that. And so I don't know. I mean, maybe what do you think? Do you agree? Do you disagree? I think
No,
obviously there's
100%.
variability, right? And some questions, especially standalones, are like not so much can you read through a passage or can you critically think about this? And some of them are more factoids that you need to know. But I
Yeah.
think
Like
those were fewer and further between.
I think honestly, like knowing the content is like having the physical ability to play a sport, but having the strategy is like actually
Yes.
knowing like the tactics and strategy, right?
Yeah, I
Like
love them.
I can throw a football 60 to 65 yards on a good day, but that doesn't mean I'm going to the
That
NFL,
doesn't mean you're an NFL quarterback. Yeah,
right?
exactly.
Like, so there's the tactical element, there's the strategy element, right? So I think they go hand in hand, right? I could know how to dissect the defense. If I can only throw the ball 10 yards, like I'm not
Right.
going to the NFL, right? Like
Right.
they
You have to
go
have
hand in
both.
hand, but within the domain of the MCAT, like most of our listeners are hard enough working to master a lot of the content, right? Excuse me, what separates people is the strategy. And so apply it again to what we talked about today, right? Write out what alpha decay means, lay it out sort of formulaically, like Eric mentioned. Uh,
Sounds
and
good.
hey, I mean, we're just adding words to the dictionary at this point, but Same with beta decay. Gamma we know is just energy, which is nice, but write it out, right? Practice with it. So, and one of my favorites is like explain it to somebody else, because if you can do that, you've nailed it. But as we've been saying for several episodes now, right? Take the content that we covered today, right, and try to apply it, in your prep and incorporate strategy within that, right? Using process of elimination. So, hey, okay, I've got a beta minus decay. I know the atomic number is not going to, or sorry, I know the atomic mass is not going to change. Let me get rid of those answer choices first. Or if it's alpha decay, I know atomic number and atomic mass need to change. Let's get rid of those numbers first.
Yeah.
Right. And then kind of working from there. But I guess to wrap up on my end, like I said, take the content we covered today, now apply it sort of thoughtfully and intentionally, right? And then leverage process elimination now when you see questions on what we covered.
Yeah. Yeah, there's a lot of strategy to learn. And I think, we're recording this in October. And so any of you who are listening to it now in October or, a year from now in October or whatever the case may be, I think this is the time to be getting the content down, to be starting. Depending on when you're taking the test, like maybe you're in full swing of studying and maybe you're not quite there yet and you're just kind of brushing up on the front end. But I think we've talked about, well, I guess maybe this was my take. I was going to say you agreed with me, but I don't know if you necessarily did. But you do kind of have to have this content down, and I think to me that's kind of the first step. That's like your foundation, and then you build on that content to better understand the test and how the test works and how you can use strategies to address the types of ways they ask questions. And so I think the strategy will come with time and with experience and with practice. And so right now you want to be surveying all of the content and really understanding things so that you can then put it into practice where you need to. And so work on the content and let that be step one, and then get down to business and learn about the test and learn how to take the test. But I agree with Ahmed 100%. You have to have both. And it's hard sometimes to juggle, like, which one of these things should I focus on? I think you have to be judicious with yourself and kind of see how you perform on questions and practice question sets and tests and things like that. But I think this early in kind of the study season in October, I wouldn't really start worrying too much about strategies specifically until the new year and as you get closer to that test date.
Yeah, I think, build your content foundations, then level or layer in sort of different levels of strategy. But to wrap up, alpha decay, losing a helium atom, right? Atomic mass down by 4, atomic number down by 2, right? Beta plus, lose a positron for the plus. That means a proton became a neutron. Mass stays the same, atomic number goes down by 1. Beta minus, you lose an electron, so a neutron became a proton. Mass stays the same, atomic number goes up by 1. And then gamma, nothing changes, just the emission of a high energy gamma wave. As we talked about, right, build that foundation of content and then incorporate the strategy from there.
I'll just say briefly. Sorry, I'm kind of laughing here because I feel like I should have mentioned as well, and I've seen a couple of questions on this, but electron capture as well as I've seen a couple of times. So just the same principle applies. Like you're adding an electron onto kind of your reactant side of an equation, or a massless negative charge, right? Whatever the case may be. And so your atomic number is going to go down because you would effectively be converting a proton into a neutron, right?
Electron capture.
What's that?
I was just gonna say electron capture is basically beta minus decay in reverse.
In reverse, exactly. And so, I don't think it was super important that we touched on it one way or another because it's kind of the same principle, right? Like you're adding a negative charge somewhere, and so you kind of have to figure out where that's going and what's going to happen to your atomic number. And that's happening in all of these scenarios. So if you kind of work on it and figure out how to conceptually think about one of these, then you should be okay with pretty much all of them.
Yeah. Couldn't have said it better. I hope that episode was helpful. I hope that decays start to make sense and, importantly, how to attack those kinds of questions, right, in a way that's straightforward and less mistake prone. And as always, continue to apply what you heard today purposefully, thoughtfully, and we hope that translates into results in the short term and ultimately on test day. We thank everybody for tuning in to yet another episode, and we'll see you guys on the next episode of the Jack Weston MCAT podcast. Take care,
Bye,
guys.
guys.